Alright, so this is where we left off on Friday. We had worked on these problems above, so I know I have it erased here, but we found the center of this one was -2, 3. The major axis we had found as 8. Minor was 4. And then we had found this one over here. So we had found both of these, but we hadn't answered the question here yet. So that's where we're going to start today. So try to think back to ellipses, how we found the center, and how we actually graphed those. So how is the graph of an ellipse different from the graph of a circle? How is the difference noted in the equation of an ellipse versus the equation of a circle? So what is one major difference that you notice from circles to ellipses? And then how do you notice that difference incorporated into the equation? That's what we're getting at. So take a minute, look at your equation, look at your graph again. Kind of notice the big differences. Try to explain what they are. So let's hear a couple examples. What are some differences from the ellipses to circles? Go ahead.
The circle has one radius, but the ellipsis has 2 different ones.
Very good. That's really important. So a circle has a radius that's the same the entire way around the circle. But an ellipse, we're finding these 2 different measurements called the major axis and minor axis. So there's actually different lengths between the center and the outside. So the vertical and horizontal distances from the center are different in the ellipse whereas they are the same in a circle. Okay, very good. So saying that the radius in a circle is the same, but the vertical and horizontal distance is different from the center to the outside edge. So very good. What else do we notice is a difference between them? Maybe with their equations. Differences between an ellipse equation and a circle equation. Right? Sorry, what was that? Oh, fraction. So we have the x minus, we're going to use h part since we don't actually have a value, squared, and the y minus k squared. Those 2 values are divided by different values. But they're divided by different values when the equation is what? There's one more stipulation. Equal to 1, exactly. They are divided by different values when the equation is equal to 1. You can also state the next sentence then to compare it to the circle. Well, in a circle, they're both divided by the same thing. No matter if it's 1 or another value, they would be divided by the same thing. So a circle is divided by the same value and equal to what? So a circle is divided by the same value and it's equal to what? Marie? Sorry, what was that? No, not quite. How? The value that it's equal to, what do we always do with it, or what does it help us find? It
Radius squared.
radius squared, exactly, because you take the square root to find the radius. So it's r squared. So in a circle, it's always equal to your radius squared. In the ellipse, it's always equal to 1. Very good. So this is basically just describing the differences. So if you see an equation, you should be able to tell if it's the equation of an ellipse versus the equation of a circle. Is there any of this you need me to repeat, restate? We're okay with that so far? Alright, so let's go ahead and start some examples then. So we're going to deal with this equation of an ellipse down here. We can see, as we stated above, it's divided by two different values. This one's divided by 4, that one by 16, and it is equal to 1. So we have the equation of an ellipse. Identify the following characteristics of this graph, and it is pictured below. So we can see the center should be at -2, +3, and if we go to our picture, -2, 3, our center is there. Alright, so let's look at some of the questions. It says find the coordinates of the vertices. Well, who remembers what the vertices are? How do we find those vertices? I mean, they give us a picture, but where are they at? If you're not sure, we had a definition on the first page when we started ellipses for vertices. The points that are the furthest away from the center. So that would be this point here and this point here. The one on the top and bottom, those are the furthest away from the center. And it wants to know what those coordinates are. Well, this one is -2, 7 and -2, -1. Okay. Coordinates of the covertices. Well, how do you find those, or what are the covertices? Who remembers what those are? Marie? Not exactly. I know what you're getting at, or where you mean they are, but that is not what they actually are. Anybody else can restate that maybe? She said that they're the second furthest away. Maybe take a look back at your definition. Anybody help her out? Covertices are what? The points that are...
Excuse the interruption. Would all boys interested in playing boys lacrosse this spring please report to the auditorium for a brief meeting? Again, that's all boys interested in playing lacrosse this spring to the auditorium. Thank you.
Alright, the covertices are the points that are the closest to the center. So that would be this point here and this point here. They are the closest. So the coordinates of that would be -4, 3 and 0, 3. Length of the minor axis, well, that's the smaller one. 1, 2, 3, 4, the distance the whole way across. Length of the major axis, 1, 2, 3, 4, 5, 6, 7, 8. If we didn't have the picture and only had the equation, how could we find these two? So let's focus just on the minor axis first. Who could tell me about that? You didn't have the picture over here, you only had this. And I want the minor axis. If you have the equation of a circle, how did you find the radius? If you had the equation of a circle, it was equal to r squared. How did you find the radius? You took the square root. In this problem here, for the minor axis, we want to find the distance across here. If we only have the equation, well, the minor axis is the smaller one, so we go to the smaller one. We take the square root, The square root of 4 is what? 2. But that's only half of it. Remember, that's only half. We want the entire distance, so you have to multiply it by 2 or add it to itself. Well, 2 times 2 is 4, so the length of the minor axis is 4. For the major axis, it's the larger one. The square root of 16 is 4, but remember, that's only half of it. You have to multiply it by 2, and that's how you get 8. Okay? Alright, so the next part is something we haven't done yet, so this will be a little different. We talked about the major axis, the minor axis, the vertices, the co-vertices, the center, but we have not talked about the focus points or the foci. So what we're going to do is we're actually going to try to find the coordinates of those 2 points. Remember, those points are close to the top and close to the bottom, but not quite there. So we're going to find the actual coordinates for those. What did we use within the ellipse on Friday for calculations? What was that formula that we were using? Should be a familiar one. We used Pythagorean theorem. Well, that's going to help us with this. With the Pythagorean theorem, we said the value of what 2 distances are the same, from where to where? In our ellipse, we know there's 2 distances that are the same, and what are they? I'm going to tell you, one of them would be from the center to the vertice. It's the same as what? The distance from the center to the vertice is the same as? Yeah, the co-vertex to this focus that we don't know exactly where it's at yet, but it's somewhere close to the top and somewhere close to the bottom, okay? So the distance from here to the top is the same from here to this one almost at the top. So if we use Pythagorean theorem, well, we know this distance here is 2. So we can have 2 squared. We want to know what the distance is from the center to this focus. We want to know what that distance is. That way we can get the coordinate. So we don't know what that is. We could say that's b squared. We don't know what that value is. What is the distance from this co-vertex to the focus then? The hypotenuse. What is that distance? We should know it. You should be able to find it out from your picture. Distance from co-vertex to the focus. Because Dylan just told us it's the same as what? It's the same as the center to the vertex, and that is what? 4. So we know it has to be equal to 4 squared. Very good. Now we need to solve for C. So 4 squared would be 16. 2 squared, 4. Solve for B. You get plus or minus square root of 12. And I'm going to simplify that a little bit. Plus or minus. You can do square root of 4 times square root of 3, which would be 2 square roots of 3. So this is part of it. What we found is we found the distance from the center to the focus. That's what this value is. The distance from the center to the focus. They want to know what the actual coordinates are though. So we know that this value is plus or minus 2 square roots of 3. So this value b, plus or minus 2 square roots of 3, is added to the y coordinates of the center since the major axis is y. So this will make more sense once we actually write the answer. This value here is added to the y coordinates from the center because the major axis is y. So our new points, if we take the point from the center, we had -2 And we had, let's see, we had the negative 2, comma 3 for the center, this point right here. So we have negative 2, comma 3, but we have to add the new value. So 2 square roots of 3. So that's the new coordinate. Negative 2, comma 3 plus 2 square roots of 3. And negative 2, 3 minus 2 square roots of 3. Those would be your new points. Those are those focus points that are almost at the top and almost at the bottom, but not quite there. Now, a key point to remember, when you're finding those focus points, the focus points are always on the major axis. So in this case, they're on the y's, up and down. But if the ellipse went this direction and the major axis was with the y's, they're going to be from side to side, not on top and bottom. So remember, those focus points are always on the major axis. So if it's the other direction, you have to add or subtract those to your x values, not your y values. Now, I know that was the first problem we did like that, but are we okay, or is there complete confusion, or at least got part of it? Going to practice a little more? Alright, so let's go ahead on to the next one. So we're going to page 225 at the top. It says, graph the ellipse defined by each equation. Identify and label the coordinates of the foci for each ellipse. Okay, so they give us the equation. Our center has to be where? Negative 2, negative 3, very good. So without me telling you, is the major axis, the longer part, going to be up and down with the y's or side to side with the x's for this problem? Alright? Yeah, we can see the y has the larger value, so it's still going to be, the major axis is going to go up and down. So if we think about the major axis, we can find half that distance by taking the square root of this value. Well, the square root of 25 is 5, so we know from the center, 1, 2, 3, 4, 5. It's going to be a distance of 5. Also 5 this way. That's the major axis. Because in whole, it's the square root of that number times 2 should be the total distance of 10. Now we need to find the minor axis. Well, from the center to the outside edge, you just take the square root of this number. Square root of 9 is 3, so 1, 2, 3. 1, 2, 3. And then you can kind of get the picture of the ellipse. So we found the center from the top, and we found the length of the axis from taking the square root of the bottom numbers. Now we need to find the two focus points, or the foci. So we're going to use Pythagorean theorem again. We know the distance from the center to the co-vertex is 3. So 3 squared plus, we don't know the distance from the center to wherever this focus point is, so the point almost at the top and almost at the bottom. That's what we're looking for, b squared. The distance of the hypotenuse is what? Who can tell me what it is this time? The distance from the co-vertex to this focus point is what? Remember, it's the same as something else. Close. Well, yes. I'm asking, yeah, what the length of that would be is 5, but if you filled an equation, yes, you would get 5 squared. So you were one step ahead of me. It's 5 because the distance from the center to the vertex is 5, and it's the same as the distance from the focus to the co-vertex. So we know the hypotenuse has to be 5, and we square it. If we solve for b, we get b squared equals, well, 5 squared is 25, 3 squared is 9. If I subtract that over, 25 minus 9, I get 16. So b is equal to plus or minus 4. So that's just part of it. What do I have to do lastly to get my 2 points? I have this value of b now. What do I need to do with it? No, I already took the square root here. B squared equals 16. I took the square root of both sides. I got this value of plus or minus 4. Yes, the major axis is on the y's, so I take my center point, which is -2, -3, and I'm going to add it to it. So I'll write out 2 steps here so you can actually see. So it was -2, -3, and I'm going to add 4, and then I would have -2, -3, minus 4. So my 2 points are actually -2, 1, and -2, -7. Those are actually my 2 answers. -2, 1, -2, 7. So if you actually graph those, go to -2, 1, I actually get a point right there, and -2, -7, I get a point right there. So we can actually find where those 2 focus points are on our graph. Very good. Alright, let's take a look at the next one. I'm going to erase this just so I have some room in that box right here. Okay. So if we look at the next one, before we start, it's equal to 1. What's our center though? Our center is where? 1, 0. We get the opposite of 1, and there's nothing with the y, so it's 0. So 1, 0, that's our center. Very good. What has the major axis? Is it going to go side to side on the x's or up to down on the y's? The x-axis. So we can see with the x values, that's the largest value. So let's go ahead and try to graph it. If I take the square root of 16, I get 4, so I know that's half of the major axis. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So that means the minor axis is going up and down. Square root of 9 is 3. 1, 2, 3. 1, 2, 3. We okay with the picture so far? Alright, so again, we want to find those focus points. So every example we've done so far, the focus has been here and here, top and bottom. But with this one, the major axis goes side to side this time. It's longer from side to side. So our focus is going to be somewhere over here and somewhere over here. That's what we're trying to find. It's on the sides now. So we're going to use the same method we did before, Pythagorean theorem. We know the distance from the center to that co-vertex is 3, so 3 squared. We don't know the distance from the center to the focus. That's our other leg, so that's our b squared. But we do know our distance from the co-vertex to the vertex, or co-vertex to the focus, and that should be what? Remember, it's the same as something else, so you're able to count it. What is that value? What is that value? 3 squared plus b squared equals what? I need something squared there. What's my value? 4 squared. Thank you. Okay. And I'm going to solve it for b. So b squared is equal to, well, I get 16 minus 9. So I get 7. So b is equal to plus or minus square root of 7. So this time, when I find my points, I'm adding and subtracting this b value to what coordinate? My x or my y? Which one is it being added to, the x or the y? Alright, it has to be your x values now because the major axis is on the x. So your x was 1, so you do 1 plus square root of 7, comma 0, and 1 minus square root of 7, comma 0. Those are your 2 points for the focus. So you're going to have some point over here and some point over here. It's going to be at 1 plus square root of 7, comma 0, and 1 minus square root of 7, comma 0. So somewhere around there and somewhere close to there. Now are we okay with finding both of them? We did with the y's when the major axis was up and down. Now we've done with the x's when the major axis was side to side. Are we okay with the differences on where we have to add them? Alright. So moving on to a different kind of example then. The one given below kind of looks like what form from a circle? We were given 2 forms when we had circles. This one looks like what from a circle? We were given center radius form and what was the other one? Rebecca? General form. So this one really looks like that general form from the circle because we have everything on the left equal to 0. And when we had that general form and we tried to make it look like center radius form, what was that trick that we had to use to convert it? Yeah, like the completing the square. Very good. So that's what we're going to do with this problem because we want to get the equation to look like the equation of an ellipse that we can graph. So we're going to have the 4x squared plus 16x plus blank, where we'll complete the square, plus 9y squared minus 36y plus a blank, where we'll complete the square, and that value of 16 you have to subtract to the other side. Before we complete the square, I'm going to make it a little easier on you, so don't complete the square yet. We can pull a 4 out over here. So we get 4x squared plus 4x plus blank. On the y's we can pull out a 9. So 9y squared minus would be 4y plus blank. Okay? That's just factoring out those 2 values to make it a little easier to complete the square. For my x's, if I complete the square, what do I get for my value? Because Tori told us it was b over 2 squared. So if I take b over 2 squared, what's my new value? Thank you, it's 4. The same with the y's. We have negative 4 over here. Negative 4 divided by 2, negative 2. Well, negative 2 squared is 4. So they both are 4. Now, we have a 4 here, but in reality, we actually added what value to this side? We didn't just add 4 over here, we added what? Because if you think about this 4, it's being what? Yeah, it's being distributed, so 4 times 4 is 16. What do we have to add to the other side then? 16, not 4. Because technically we've added a 16 over here because it's being multiplied. What did we add with the y values? We didn't add a 4, we added a what? We added 36 because 4 times 9 is 36. Very good. Now we can start to factor and try to make it look like the equation of an ellipse. Yes?
Okay, I'm not confused. Say you did it before,
Yeah.
took out before.
Yeah, you can.
It'd be 6 over 2 squared. It'd be 8 squared. It'd be 6.
Let's see. We can try it that way. I'm not sure yet. Let's see.
I'm just confused.
Then this one over here would be a much larger number 2. But I think when you reduce and factor everything, because it's going to eventually cancel out, because we're eventually with an ellipse going to do division, and I think in that division those numbers will eventually cancel out, the same as factoring out in this version. If we have time, we can go back and do the other method to see if we get the same answer, okay? Alright, so let's finish out this method right here, because so far mathematically, have we really done anything wrong though? We factored out, you can do that. We've completed the square, and we've added to both sides. So mathematically, we haven't done anything different at this point. Okay, so let's go ahead and try to factor this side. We still have the 4 out in front, and we want to factor this part here. If we factor that, we would get x plus what? X plus what? 2, and that's squared. Okay. On this side, we still have the 9 out in front. And if we factored this one, we would get y minus 2 squared. On the right side, some stuff's going to cancel out, and we're just left with 36. And now, we always want the equation of an ellipse to be equal to what? Equal to 1. And we normally have fractions in it. So how are we going to get this equal to 1? What can we do?
Divide by 4 and 9. Get the fractions and make it equal to 1 because 4 times 10 is 36.
Okay, so you're on the right track. What would be an easy thing to divide by to make that side 1 though? Tori? If you just divide this side by 36, 36 divided by 36 makes that 1. And we'll divide both of these by 36. And like you said, 4 and 9 are factors of 36, so it should simplify. So we're going to divide by 36, and divide by 36, divide by 36. On the right, that's an easy one. Simplifies to 1. 4 and 36 would reduce to what? Yeah, we would just get 1 over 9. Well, 1 would be times this x plus 2, so you're left with x plus 2 squared over 9. Very good. And with the y's, you are left with y minus 2 squared over what? Because you divided that by 36. 4. Very good. Do I need to take a step back, or are we okay with how we arrived at that? So we completed the square. I had factored out the beginning just to make it easier for the b over 2 squared. We factored, and we were able to divide to make the side equal to 1. And when we divided, we were able to cancel these coefficients here. So we get the form of the ellipse now. Now it looks like something we can use. We can graph it. Our center is at negative 2, 2. Okay? Our major axis is with what? The x or the y's? Major axis with the x or the y's? Careful. If we look at the y's, the value is smaller. If we look at the x's, the value is bigger. So the major axis is going to be side to side. So if we take the square root of 9, that's 3. 1, 2, 3. 1, 2, 3. That's the major axis. The minor axis, square root of 4 is 2, so half of it, 1, 2, 1, 2. we have our picture. We're almost done. At the very top, they're asking for the coordinates of the foci, so that's what we still need to find. We've gone through a lot in this problem. It was expanded, we completed the square, we factored, we've made it look like an ellipse, we've graphed the ellipse. Lastly, we need to find the foci points. So, we know we have to do Pythagorean theorem. We know the distance from the center to the co-vertex is 2. That's 2 squared. The distance from the center to this focus point somewhere over here, we don't know exactly where it's at, but it's less than that vertex. We don't know that distance yet, so that's our b squared. But we do know the distance from our co-vertex to our focus is what? Remember, it's the same as something else, so you're able to count it. It's what? What value is that we have to square? Anybody? 3 squared. Now I'm going to solve for b. So I get 9 minus 4. Take the square root. So my foci points, they're on the x's, so I'm going to have my -2 plus the square root of 5, comma 2. That's my first point. And -2 minus square root of 5, comma 2 is my second foci point. Is anybody completely lost, or we at least have the general idea? Alright, so before you start packing up, we have a couple minutes here, so what I'd like to do, we're not going to have time to finish this back page. There's 4 examples of similar problems we've done. So it's still dealing with finding the major axis, minor axis, finding a center, being able to graph it, and finding the equation. But we're not going to have time to make it through that today, and I want to take time to go through those 4 examples. So you have the remaining time. If you want to work on a couple homework problems to make sure you understand and can grasp how to do this, you can do that. But we'll finish tomorrow. The remaining time tomorrow will be homework time or study time for the quiz, and your quiz will now be Wednesday.